Right, the oscillations of a heavily damped pendulum satisfy the following differential equation. d2x dt squared plus 6 times dx dt plus 8x equals 0. Find the general solution for this differential equation. Okay, now, I was looking in John Bird's book. The book is called Higher Engineering Mathematics, page 47... something or other, page 479, right? Page 479 in the book by Bird, and this question is done there, right? So I'll just go through it. So this is called a second order differential equation, because this is d2x, right? And it's called a homogeneous second order differential equation just because the right hand side of the equals is 0. A homogeneous second order differential equation. Anyway, there's a wee procedure for doing this, and the first step is to write this equation in D operator form. We're going to write it in D operator form, right? D operator form. So that instead of d2x dt squared, we're going to have d squared plus 6 times d plus 8, and then we're going to have brackets. We'll have our x here equals 0. Now, I'm not sure exactly why this works like this, right? We're just going to go with it. And then, well, d equals d something dt, right? And then we're going to solve what's called the auxiliary equation. So the auxiliary equation is going to be m squared plus 6m plus 8 equals 0. This is called the auxiliary equation. Okay, so we'll solve this one now. Now, what two numbers add together to give plus 6 and multiply together to give plus 8, right? And the numbers are going to be 2 and 4. So we can rewrite this as m squared plus 2m plus 4m plus 8 equals 0. From the first two items here, we can pull out an m. So that's m times m plus 2. And we want an m plus 2 in the second as well, right? To repeat the pattern. So we'll pull out a 2. 2 times... No, we're going to pull out a 4. Right, we'll change that into a 4. So 4 times m is 4. 4 times 2 is 8. So we can write that as m plus 4 times m plus 2 equals 0. Either one of these is equal to 0. We set both to 0, so m equals 4 equals 0, or m plus 2 equals 0. And that gives us m equals minus 4, or m equals minus 2. So these are our roots. Now, these are different roots, right? So they are real and they're different. We'd agree that they're real because there's no square root of a minus number, so they're real numbers and they're different. So this triggers a certain general solution. As we're going to add in an image now from the back of the exam sheet. Where is it? Second order differential equations. There we go. Right? This rule here. So I'll put it up here. Just bang it on top there, right? We're looking for the general solution anyway. If the roots are real and different, we're using this rule here, right? This top one. So the solution for us is y is going to be equal to a times e to the alpha x plus b times e to the beta x. Now, the x is the variable. in our case the variable, yeah, we're still talking about x's, and we're talking about dy dx, dx dt, dy dx, dy dx. You see, we don't have dy dx, we have dx dt. So we're going to have t's in here instead of x's, right? And instead of y, we're going to have an x here. So for our particular situation, we have x equals a times alpha t plus b times e to the power of beta t, right? Now alpha and beta are the roots that we found, and they are -4 and -2. So we can write this is our general solution, and that's equal to a times e to the power of -4t plus b times e to the -2t, right? And I'm looking at the book, and it's very similar to this. So just going to blue here. That's our general solution for that equation up there.